Okay, so in section 2.4, we're going to be focusing in on measures of variation in the data set. When you hear that term variation, all that's talking about is how spread out the values in your data set are. So, if you think about placing points on a dot plot, some data sets are very spread out. Their values are very different from each other. Those data sets have high variation. Other data sets, again, think about placing points on a dot plot. All the points stay very close together. They're not very spread out, and those data sets would have low variation. So in section 2.4, we want to put a number to this measure of variation, and that's what we're going to be looking to do here. So we're going to start with a very simple measure of variation, and that is just to look at the range of a data set. Now the range does nothing more than look at how far it is from the smallest data value to the largest data value. So if you were looking at these 10 starting salaries and you were asked to calculate the range of those 10 salaries, all you would do is scan through your data values, locate the largest starting salary, locate the smallest starting salary. Oops. And again, range is just going to be the difference between those two. So one way to measure variation in this data set of salaries is to say there is a range of $35,000 from the lowest starting salary to the highest. Now, while the range is very quick and easy to calculate, and it does give us some idea about variation, we're going to continue this and come up with a measure of variation that actually looks at each individual data value. And that measure of variation is something that we call standard deviation. All right, now what you're seeing on this page of your notes is the formula. All right, the formula for each one of these. And I'm going to come back to these formulas and explain everything in just a minute. What I want to do first, though, is just go ahead and show you what the actual calculations are going to look like. And then we'll go back and talk about how this relates to that formula. All right, so same data set that we're looking at here. But notice instead of being asked to calculate range, we are asked to calculate two other measures of variation, which are variance and standard deviation. All right, now, like I said, the first thing about variance and standard deviation is they measure variation by looking at each individual data value. So a lot of times what we do to make our calculation a little bit easier here is we set up a table. And in that table, the first thing that we do is just make sure that we look at each individual data value. So all I'm doing here in the first column of my table is just transferring over each of the 10 starting salaries that we have in this data set. Now, the way that standard deviation looks at variation is it looks at how much do values differ from the mean, from that central value. So in order to calculate variance or standard deviation, the first thing you're going to have to do is go ahead and calculate the mean of the data. Now we know from last class, mean is just an average. Now as far as notation, notice this data set tells us we are looking at all salaries for this corporation. Thus, we have a population data set. And so my mean here would be denoted as mu, and it would take the sum of the data values and divide by the number of values that we have. All right, so if I take my 10 starting salaries, I add those up, I'm going to get a sum of 415. In the number of data values is 10, so I'm looking at a mean starting salary of $41.5 thousand. So that's my center, my expected value. All right, now to calculate variance and standard deviation, what I'm going to do is take each one of my data values and subtract this mean mu. Now, I'm writing this using the notation because I want you to be able to see how this relates to the formula. But I also want you to not get too hung up in all of the notation. So when you see something like this, you want to remember X simply represents a data value and mu represents a population mean. So all we're really doing here is we're taking each data value X and we are subtracting the mean data value, which we just calculated at 41.5. Okay, so for example, I would take 40, I would subtract that mean of 41.5, and my difference, it's called a deviation, is negative 1.5. Now, I would do the same thing with every data value. All right, so my next one, I'm going to take this value of 23. I'm going to subtract that same mean of 41.5, and I'm going to report my difference, which is negative 18.5. Okay, so again, all I'm doing is I'm taking each data value, and I am subtracting that same mean of 41.5, and this is what I'm putting in my second column. All right, so I'm going to go ahead and fill this in with each one of my differences or my deviations. Notice some are negative, some are positive, based on whether my value is above the mean or below the mean. Now, when you're looking at just the deviations, which is what we have here, some positive, some negative, if you try to take their sum, the sum will always be 0 because that mean does mark the center and we've got balance on either side. That is why you're going to have one additional column in your work table here where instead of just using the deviation, the x minus mean, you're going to take each of those values and you're going to square. Okay, so in my third column here, all I'm doing is I'm taking whatever I got for my deviation and I am raising it to the second power. Now remember, when you square a negative number, you end up with a positive number. So if I take negative 1.5 and I square it, I'm going to get a positive 2.25. All right, similarly with my second deviation of negative 18.5, if I square that, I'm going to get a positive deviation of 342.25. All right, and just like I did for the second column, I'm just going to continue this all the way through my table. So 8.5 squared gives me 72.25. And I'm going to continue filling in until I have squared each one of the deviations in my second column. All right, now this is the work that you're going to do every time you need to calculate variance or standard deviation. All right, first column, take your data value. Second column, subtract the mean. Third column, square. Now, using this information from here, we are going to calculate the variance of this data set. Okay, and here's where we're going to go back and we're going to look at our formula. Okay, so first thing to note, we said we're looking at a population data set, and what we're calculating is the variance of that population. Okay, so this formula right here is what I'm using. Now, first thing is notation. You're seeing a new symbol here. This is actually the lowercase Greek letter sigma, and sigma squared is the notation that we use for population variance. Okay, so I'm going to pull that formula back over here, it says sigma squared, population variance. We'll take the sum of the deviation squared divided by n. Okay, so to get my sum, all I need to do is add up the squares that I have in this third column. All right, so if I take my sum, I'm looking at a sum of 1102.5. All right, so I'm going to come back over here to my variance formula. All right, again, my sum is 1102.5. That's that whole number on top. All I have left to do to get my variance is divide by n. And n here corresponds to the 10 data values. Now, the trouble with variance is that everything is squared. So technically, if we put units on this, it would be 110.25 thousandths of dollars squared. So variance for us right now is more just a stepping stone to get to our standard deviation. All right, now again, I'm going to go back to my formulas. And what I want you to notice about the formula for standard deviation is that it always corresponds to just the square root of my variance. So again, notationally, it's just sigma. Basically, you get rid of the square, and the way you get rid of the square is by simply taking the square root. So once I found variance, to get standard deviation sigma, all I have to do is take the square root of my variance, all right, the 110.25 that I just calculated, and that's going to give me a standard deviation of $10.5 thousand. Now, again, remember standard deviation is talking about spread, variation. So the mean tells me that my central salary is about $41.5 thousand. The standard deviation tells me how much the values differ or vary around that mean. So we would expect our salaries to go down about $10.5 thousand from that mean, and we would expect our salaries to go up about $10.5 thousand from that mean. Okay, so again, standard deviation, how much do the values differ from that central mean? All right, now I want you to go ahead and do a little bit of practice with this variance formula. Just go into your practice problems and look at the problems that ask you to do variance and standard deviation for a population. What we are going to focus on next class is this same calculation, variance, standard deviation, but instead of for a population, we're going to look at how this differs for a sample. Now, obviously, there's going to be some differences in notation. Instead of sigma, we'll just see an S. Instead of population mean mu, we'll just see sample mean x bar. But as far as the calculation, all right, what I want you to keep in your mind is that everything will be done exactly the same for population and sample until you get to this number right here. So you'll do, take your values, subtract the mean, square, add everything up. But if you're dealing with a sample data set, then when you get to this step right here, where we divided by n, 10 values, for a sample, you're going to go slightly lower and divide by n minus 1, one less than the number of values, which will give you a slightly larger measure of variation. Okay, so again, practice this for a population. We're going to pick up from there and talk about this in terms of a sample next class. And of course, we'll go over any questions at that time as well.